The next section is about the Pythagorean Theorem, which is one of the most famous theorems in geometry. It's for finding missing side lengths in a right triangle. It only works for right triangles, but we can use the converse of the Pythagorean Theorem to tell whether we have a right triangle. Pythagorean Theorem is used to find missing side of a right triangle. So that's the purpose of the Pythagorean Theorem. It is not for angles, it's for finding missing sides. So a right triangle is a triangle that has a right angle in it. You can only have one right angle because you have to make sure that your angles add up to 180. So you can have one 90-degree angle in your triangle. When you're labeling your sides for the Pythagorean Theorem, A and B are called legs, and they're both called legs, and you can put A and B on either one of those two sides. They're the two sides that make up the right angle. We have to put C on the longest side, or the side opposite the right angle, which is called the hypotenuse. So the hypotenuse is the side opposite, sorry, I got distracted, the side opposite the right angle. So if I find my right angle and then I look to the side it's looking at, that would be the hypotenuse. The hypotenuse is also the longest side of the triangle. And we always want to call the hypotenuse C. I don't care which one you call A and B, but C, which is the hypotenuse, has to be called C. So an example, so the formula, the Pythagorean Theorem says that in a right triangle, A squared plus B squared has to equal C squared. And we can use that to find any of the missing sides in a right triangle. So in example 1, the first thing I'm going to do is label which side is C. Here's the right angle. The side opposite that is going to be C. So that side is C, and then A and B are going to be the other two sides. I'm going to use my Pythagorean theorem, A squared, so 12 squared, plus B squared, so X squared, is equal to C squared, so 15 squared. Grabbing a calculator or just knowing my perfect squares, 12 squared is 144 plus X squared is equal to 225, which is 15 times 15. If I subtract 144 from both sides, I get that X squared is equal to 81. Now, in order to solve this, I need to take the square root, and I want the positive answer because X is a distance. So X is going to be the square root of 81. Now, if I don't know my perfect squares, I might not know that 81 is 9 times 9. But it is, so that means that X is 9, because that's a perfect square root. If I'm doing example 2, I have two sides that are 8. Those are both legs of my triangle, but it's very important that I treat Y like the hypotenuse, because it's opposite the right angle. So when I set up my Pythagorean theorem, it's going to be 8 squared plus 8 squared is equal to Y squared. 64 plus 64 is equal to Y squared, or 128 is equal to Y squared. And then I might not be great at my perfect squares, but I know that 64 goes into 128 because we just added two 64s together to get 128. So 128 is 64 times 2. And then I can take the perfect square root of 64, that's 8, but I can't take the perfect square root of 2. So that's going to be 8 times the square root of 2. Oops, I keep writing squareds here. These are no longer squared because I took the square root. So that is the exact answer. If I grabbed a calculator and just did the square root of 128, that would be an approximate answer. It wouldn't be the exact answer. 18 times the square root of 2 is the exact length of that hypotenuse. The other thing the Pythagorean theorem can tell us is whether we have a right triangle or not. So if we do a squared plus b squared and we get c squared, then we right away know that we do have a right triangle. If we get a squared plus b squared and it's smaller than c squared, then we know that we have an obtuse triangle. What an obtuse triangle means, so a right triangle means that we have a right angle in our triangle. An obtuse triangle means that we have one angle that is bigger than 90 degrees in our triangle. And if a squared plus b squared is bigger than c squared, then we have an acute triangle, which means that all of the angles are less than 90 degrees. So if I'm going to do this, I have some side lengths here. First thing I'm going to do is I'm going to circle C, which is going to be our biggest side length. And then I'm going to find a squared plus b squared, so the other two sides. 8 squared plus 9 squared. So 64 plus 81. And when I add those together, I get 145. And then I'm going to compare that to c squared. So c squared, it would be 15 squared, which is 225. Since we have less than, so 145 is less than 225, we know that this is an obtuse triangle. Okay. If I look at example 2, the biggest number is 50. So I'm going to do 14 squared plus 48 squared, and I'm going to grab a calculator for that because I don't know those numbers off the top of my head. I get 2,500 when I do that math. And then I'm going to compare that to c squared, so I'm also going to look at 50 squared, and when I do that math, I also get 2,500. So that means that since 2,500 is equal to 2,500, this is a right triangle. So that's how you classify triangles. The 8-1 practice is here, and I'm going to do just the first one, and then I encourage you to try the others, pause the video, and then restart so that you can check your work. So if I do this first one, I'm going to make sure to label X as the C side of the triangle because that is the hypotenuse. So I have A, B. So I'm going to do 8 squared plus 15 squared is equal to C squared. So I have 64 plus 225 is equal to C squared. So 64 plus 225 is 289. And I might not know if that's a perfect square root, but I could try on my calculator to do a square root of 289. And I actually do get a nice number. So C is equal to 17, because 289 is 17 times 17. Okay, I'll pause the video. You try 2 through 4 and restart after you have tried those problems. Pause now. Here's my work for number 2, 3, and 4. Some things to remember is that you want to be able to simplify the radicals. So go back and watch the simplifying radicals lesson if you're not sure how to do that. And then what I noticed on number 4 is that I wasn't sure which perfect squares go into 108, but I knew that 4 did. And then when I looked at 27, I knew that 9 went into 27. So I was able to break it up into 2 different perfect squares and then a 3. I took the square root of 4 and the square root of 9, and that gave me 6 times the square root of 3. All right, that's my work for 1 through 4. The next problems I am going to draw a picture for. So I have a square, so I know that both of these are the same length. And then I know this is 20. So A and B are the same length. I'm going to call them both A. So A squared plus a squared is equal to 20 squared. So that means 2a squared is equal to 400. And then if I divide by 2, a squared is equal to 200. And when I take the square root of that, I know that for 200, I know that 100 goes into that number. So a is going to be the square root of 100, which is a perfect square, times 2, or a is going to be 10 root 2. Okay. When you're doing, I'm going to leave number 6 for you to do. And when you're doing number 7, 8, and 9, make sure that you circle your largest number first and you treat that like C. So if I do 10 squared plus 8 squared, I get 100 plus 64, or 164. And then if I do 12 squared, I get 144. Since 164 is greater than 144, I know that this triangle is acute. Okay, so that's the method you're going to use for 5 and 7. You can try 6, 8, and 9, and then restart the video after you have tried those problems. Here's my work for 6, 8, and 9. Please make sure you ask questions if you have them. Otherwise, good luck on tonight's homework. Thanks so much. Bye.